Hello and welcome. In this session, we are going to learn what is a streaming replication in PostgreSQL. This is just a diagrammatic representation of the streaming replication in PostgreSQL, though not much details have been mentioned. It is just like there will be a primary database which will be responsible for read and write operations, and from whatever changes are happening there will be a wall file generated, and through the wall sender it will be sent on to the replica wherein it will be received and it will be applied. So that's a kind of streaming replication which happens in Postgre. So let's coming back to the notepad where we have all the details noted. So we are going to talk about the streaming replication in Postgre. For this demo, we are not going to do the live demo. The steps are already executed. In the next demo, we are going to show it step by step. But here, this is a presentation how we are going to do it step by step. So Postgre replication is the process of copying the data from primary to the another host, which is known as the standby. So this particular feature was launched in Postgre version 9.0, and streaming replication was introduced. So how does the streaming replication works in PostgreSQL? So every transaction is in PostgreSQL is returned to a file which is known as wall, which is known as write ahead log to achieve the durability. And when a slave uses these wall segments to continuously replicate the data which is changing on the master, then it will be replicated onto the slave. So in streaming replication, there will be three kind of terminologies which will be used, and that actually works. So there is a wall sender process on the primary server which sends the wall data, which is like whatever transactions has happened, whatever has changed the data on the primary, that will be sent to the standby server. And then we have a wall receiver and a startup process which will be running on the standby server that receives and replay these data. And this wall sender and wall receiver that communicates using a TCP connection. And we know that PostgreSQL has both logical and physical replication, and those are the two important replication. In logical replication, it streams a high level change from the primary database to the replica database. So using logical replication, you can change the streams to whatever is happening on a single database or in a table. So in physical replication, changes to the wall log files are streamed and replicated to the replica cluster. So you can't replicate a specific area of a primary database cluster, but all the changes will be replicated. So streaming replication allows the standby server to stay more up to date than it is possible with file-based logs shipping. So that's the general terms about the logical and the streaming replication. Now we will see how to do these step by step. So I have two EC2 instance which I have launched. So these are the two EC2 instance which I have launched, and these are the public IP address which will be immediately destroyed after this demo. So this is the public IP of my primary server, and this is the secondary server. So these are the two EC2 instances which are launched having the Linux as the operating system. So on the primary, these are the steps which you would have done at least uh, I believe some 30 or 40 times in this entire way through me. So what is the first thing which we are going to do is sudo dnf install -y and the complete location of the RPM, which is your latest RPM for Postgre 13. Then we are going to disable the Postgre, which is the default module available, and then we are going to install the Postgre 13. These are the three steps, and then we are going to initialize the database using PostgreSQL 13 setup init db, and then we are going to enable and start the Postgre 13 on primary server. So I'm already, so let me exit out of this, and if I say sudo okay, so let me show you. So you can see Postgre 13 is already active and running, and if you see it further on the, instead of I'll say it replica. On the replica, what we have done is we have executed these three steps. One is sudo dnf install -y, and the repo RPMs for latest Postgre 13. Then we have disabled the default Postgre 13 on Linux. Then we are going to install the Postgre 13 server on replica server. The two steps which we are not doing is we are not initializing the database, and we are not starting and enabling the Postgre 13. Since there is no initialization, so there is no concept of enabling and starting it. So it is just the software is available on Postgre 13. The second thing which we will do is on the primary server, we will just ensure that our postmaster is running. That means PostgreSQL is running. So you can see that postmaster is running, and there are different background processes which are mandatory, and the something which is of very interest for this streaming replication is wall writer. And one of the things which you have to do is you have to ensure that SAS status, because you are doing it on EC2 instance, you have to ensure that SAS status, this should be disabled. So in case you have, and you are not sure how to do it, just go and make it to disable. So you can see C Linux, this should be disabled for this. Or if you have a firewall, make sure that the firewall is stopped, so that the 5432 port where your PostgreSQL is communicating, that should be able to communicate between the two nodes. Then what we are going to do is, this is a very, very important part wherein we are going to enable primary for the replication as below. So what we will do is, let's log into PSQL, switch to the service account, Postgre, and then this is going to be very, very important. You just say show config underscore file. So by default, you just graph for listen underscore address, cat, and graph for listen underscore address. So there is something called as listen underscore address on your PostgreSQL.conf in your source and target. In your source, you have to ensure that listen underscore address has to be changed, because by default it will be local. And if you see it, uh, mm, local underscore address, that you have to change it from localhost to the IP address of the server. So in our case, we have just changes to star, or the IP address of the server, so that it allows the remote connection. Then the second thing which we have to do is we have on the source server. So everything we are doing it on the primary. So we are going to create a user, which we are saying as create user replication. So what this is going to do is this is going to create a replication user which will be used to replicate the data from primary to the replica. So this user is already been created. So if you say psql and /du, you will be able to see that a replication user, which is called the rep user, has been created with the replication capability. Then the next thing which you have to do is you have to tell your hba.conf file that allow the connection from the replica. So what you will do is, this is going to be very, very, very important. Cat pg data hba.conf. So you have to ensure that host replication wrap user, and this is the IP address from where your replica will be coming. You have to say that whenever the replica is coming from this, ensure that the connection is allowed. So you have to ensure this, otherwise it is not going to work. Then finally, on the primary server, you have to restart your PostgreSQL. So far we have uh, installed the PostgreSQL binary on the source environment. The database is up and running. On the console PSQL, we have changed the listen address either to the IP address of the primary host or ensure that star is mentioned so as to allow it. Then the next thing which we have done on the primary side is we have created a user called wrap user with the replication capability, and then in the hba.conf we have allowed the IP address of the replica so that it can connect. And finally we have restarted the primary server. Now on the replica side, let's open the replica. This is our replica. Here also you have to ensure that SAS status, it must be disabled so as this demo to work. And we have to create a base backup. So far in replica you just have the binary and nothing else, so these things are not going to work over here. So initially when there is nothing, you go and check it over here, this will be blank. As of now there will be data because the command has already been executed. And the next thing which you have to do on logging onto the replica is you have to execute this command. PG base backup, I'm not going to execute it. I'm just going to show how it is going to work when you put it onto the replica side. You just say PG underscore base backup hyphen H. You have to mention the IP address of the source. Then you have to mention the username. This is the username. Then you have to say checkpoint, it is equal to fast. Then you have to mention the data directory, where the data will be replicated, then hyphen R, and then the slot, and you can give some name. In this case we have just given the some name only. So what this will do, this PG base backup, this will connect to the primary IP and copy all the data files from the primary, right? And the connection happens through Postgre database user, which is named as wrap user. So initially this directory on the replica was empty. Now it has been filled up. So now if you go over here and just check it out, and if you just check it out, the data has been filled up like this. That means the data using the pg underscore base backup command has been copied from primary to the replica. And how to verify that everything is working fine or not? So initially this was blank, and when you executed this has been filled up. And apart from that, there is one more important file which comes over here, which is called as, I'll show you that. Um, the one which is copied over here, it is called as postgresql.auto.conf. So it has the listen address of equal to star, then primary connection info. It is saying that when it is going connecting to the primary, it is using the wrap user, it is using a password file which is used for this purpose. Then there is a channel binding, and this is the host where it has connected. This is the port number, this is the SSL mode, and these are the basic details. Okay, and finally we have to start the replica. So there is a extra file which comes, which will not be visible on the source, is this file, standby.signal. So I think it is already lost because I have I believe I restarted it. Or standby.signal. Okay, sorry. This is empty by default. So this is created, which signals that it is a standby environment of your primary. And finally, you have to start your replica. So how do you start your replica? Initially, you were not able to start your replica because there was no database on it. It was just binary. Using the PG based backup, you have brought the data from your primary to the replica environment, and you have to just using this command, you just have to uh, start it up the normal way. And if you say sudo systemctl start PostgreSQL, this will be started. So in our case, we are just going to check the status. Running. So I have just completed it a couple of hours back. And then finally, if you say PSAXF grep postmaster or post, this will, okay, let me switch to su space minus postgre, sudo su space minus postgre, and you say just postmaster. You will be able to see the background processes, and there is important background process which you need to check, that postgre wall receiver streaming that should be working, because that is something. So there are two things. One is wall sender, which will be there on the source side, and there is something called as wall receiver on the target side that must be running, that ensures that this is a replica and it is in the standby mode, and it is replicating the data from the primary using the wall receiver process. Now, how to ensure that Postgre application is successful? What you have to do is, on the source side, you will just say, so these are the two important commands which confirms that it is in the replica mode. Expanded display you must set on, and then you have to simply say select star from pg underscore stat underscore replication. So this view tells that replication is running. This is the process ID, this is the user SysID. Who used this replication? This is rep user. This is replication name is rep receiver. The client address is this one. This is your target side, and status is streaming. It is in the asynchronous mode. And then finally, when you check it on the replica side, you set the extended mode on, and then you simply say select star from pg underscore stat underscore val underscore receivers. And if you see the detail, like status is streaming, and slot name we have not given anything, and you can see the details who has caused this replication to initiate. So we used rep user to initiate the replication. And if you, in case you wanted to check whether replication is working fine or not, you can create a table. That's the basic thing on the primary side, and the same will be replicated on the target side. But in our case, we have just seen that the status is working, so everything is fine. So just a recap, like what all has been done so far. Streaming replication is very important in PostgreSQL, because this is going to be the base for wrap mgr, which is going to be used for failover and other stuff. So before that, we should know like how the streaming replication works in Postgre. In our case, we use two EC2 instance. We have launched two EC2 instance which were running on Linux, and then we have carried out few steps. The few steps were just we executed 6 steps in primary, wherein we installed the binary, we initialized the database, we enabled and started the database. On the target side, we just installed the binary, and on the primary side, we checked what is the status of postmaster. We disabled the SC Linux on both source and target, And on the primary side, we have changed the listen address from localhost to star, or the IP address of the source. Then we created a replication user, which is going to cause the replication data to move from source to target. And then we have allowed the remote connection in pg_hba.conf in our source, and we have mentioned the IP address of the target. Then we have restarted the Postgre server on source, and then on the target side we created a PG base backup using this command, -h. This is the primary host IP. Then we have used the replication user, which we created on source side. So using this is connected to primary side, and it is doing the continuous checkpoint, and this is the current location of the data directory wherein it will be dumped, and we have given a slot name for this to happen. So these are the details which are mentioned. -d, it is the for the destination directory. -r is for replica for the replication, and then finally the val comes into the picture. So once it is done, it gets executed within few seconds only, because there was no data at all. And on the replica side, there will be one important file which will be created. That's an empty file, which is standby.signal, which represents that it is a standby environment only, and it is going to receive the data in continuous mode from the master, and that's the way it is going to work. And if you see the PostgreSQL.auto.conf, this will have the commands which are being used. And then we have started the replica. To start the replica, there should have been the data directory, which has been brought by pg_base backup. And then when finally we checked using the two commands, one is select star from pg_stat_replication, and other is pg_stat_val_replication. So using this command on source and the replica side, we verified everything is fine and working. So this is on our source side, and this is on our target side or replica side. So I hope this is going to help